What we're looking at today is, let's name one, the law of sines. So all of the trigonometry that we have done up to this point have only allowed us to solve right triangles, like Pythagorean theorem and typical values on our calculator. And so what we're going to do today is use the law of sines that will allow us to solve non-right triangles. How this works is it basically divides it into nice right triangles using the altitudes, but we're not going to get into that proof so much. So the law of sines basically reinforces the idea most of the time that the largest angle is opposite the longest side. And we're going to need to keep that idea in mind as we go along. So, for example, looking at triangle A, B, and C, what we would expect is that angle B would be the largest. Okay? And we would expect that angle C is the smallest. So what we're going to do is we're going to form these ratios about the opposite sides. Okay? So here is the law of sines in this great big bold item. So we have this ratio of the side length to the angle. So the capital letters represent the vertices, as shown to the right. And lowercase letters represent the side opposite them. So what we have here is just a ratio of proportions, almost like a double proportion. And we're going to work with this idea with the given information. So for example, let's consider the law of sines given this information. So if I wanted to fill out what we already know, I would say that the sine of 35 degrees over side A, which I don't know, is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. So if you look at this, what you're going to notice is I have a complete ratio right here. So we're going to use what we know about the degrees of a triangle along with these ratios to solve for the missing part, one piece at a time. So looking at this, first thing I notice is that I know there's 180 degrees in a triangle. So 180 minus 80 is 100, minus this 35 we already used, leaves us with a 65. So what I know is that angle C is really 65. Now we know all of our angles, okay? And we can start with either one of these ratios at a time. I'm going to go with this one first. Use our cross products, or basically we're just getting rid of the fractions. So 24 times the sine of 35 degrees is equal to A times the sine of 80 degrees. I'm going to divide by the sine of 80. So I'm going to type in 24 times the sine of 35 divided by the sine of 80. Which means, type it in here, now to make sure we close the parentheses on that. And what we're going to have here is approximately 13.98 is equal to A. Okay? The next thing we have is to work with this remaining side over here. And we basically do the exact same thing, but instead of saying the sine of 35, now it becomes the sine of 65. So typing that in a calculator, making sure to use parentheses accordingly. 24 times the sine of 65, close my parentheses, divided by the sine of 80, is equal to 22.09 is about equal to say C. So we know what we started with. We have our final answers in the end. Ultimately, we know all of the side lengths and all of the angles, but we could not use Pythagorean theorem. This is the idea behind the law of sines. So I want you to work from there.